If you're building any spreadsheet model other than a simple single-use workbook for your own use, you need to be building in error checking, both to ensure that the workbook functions as expected and that your users are entering appropriate data. Error checking can fall into one of two categories: verification and validation. With verification, there is a known accurate output to user input, so you're checking that the answer is right. Whereas with validation, user output must fall within an acceptable range of values to be deemed correct. Let's take a look at some examples and how we can check for them. Here we have a small set of financial data known as a trial balance, which by its very name must balance to zero, in that the sum of the positive values in the debit column must equal the sum of the negative values in the credit column. So it's a prime example of how we can use verification. Here we have a formula that's summing up all the positive values and all the negative values. So the sum of all those must balance to zero for the trial balance to be correct. And in this example, it does. Here's a slightly more abstract example of data verification. It's a user form where there are 3 input boxes, and we want to check that the user has filled in all 3 boxes. So I've put a value in each box, and I'm using the count blank function count if any of the cells in the range C4 to C6 are blank, which in this instance they aren't, so it returns the value 0, so the form is okay. If I delete the contents of one of the cells, it counts one blank, which would be flagged up as an error. Count blank only works for one continuous range of cells. So in the second example, I've used count A, which will allow us to refer to different ranges of cells or different individual cells. So I've built the formula knowing that I have 3 cells which must be filled in, and then count A to count whether each of the 3 cells has a value in. So 3 minus 3 is 0, so returns no error. If I delete the value from one of the cells, we've got 3 minus 2 completed cells, so we get a 1, which would be deemed as an error. Here I'm testing whether the numerical inputs on 5 cells are exactly the same. In real life, you probably wouldn't do this. You'd ask the user to input the value once and then refer to it with a formula in other cells. But where it could be useful is checking that the outputs of certain formula are identical. Here I'm using the average deviation formula because the average deviation of any number of identical numbers is 0. I've got 5 inputs of 100 here, which are validating as 0. If I change one of the values, the average deviation changes. If I make one of the values minus 100, again, it doesn't validate. So like in my previous example, you can verify if this value is 0, then all the values are the same. You may not want 0, you may want a true or false value returned. So here I've wrapped the average deviation in an if function to say if the average deviation is 0, return true, otherwise false. And you could do this with the formulas in the previous example. A simpler way of doing this is just to have a formula with the average deviation on one side and 0 on the other. So if both sides of the formula return the same value, the output will be true. So here the average deviation is 0 on the left-hand side of the formula, 0 on the right side will return a true value. And just to demonstrate, if I change one of the numbers again, it doesn't validate, so it returns a false, indicating that there's an error. The downside of the average deviation method is that it only works with numerical values. Let's next look at how we can verify any type of cell input. Here I'm using the exact formula to check text inputs. So it's taking the input from cell C2 and then comparing it to each of the inputs in C3, C4, C5, C6 individually. It's easier to demonstrate this if I deconstruct the formula. I'll put the exact part over here, and you'll see with the dynamic arrays that it's returning a spilled range of values. So it's comparing C2 to C3 is true, C2 to C4 is true, C2 to C5 true, and C2 to C6. I change one of these, you'll see that it's returned that check as false. Reset this. Get rid of the spilled range. I've wrapped it in the AND function. It's checking that each of the values is true and match each other. So if any one of them is false, the wrapped function will return false. If you're on a version of Excel that doesn't have the dynamic array functions, you can make this example work by using CSE or Control-Shift-Enter on the formula to wrap it in braces. Excel will then know that it's an array formula and will function. Whilst this exact example will work for any type of input, if you do have the dynamic arrays, by far the best solution is to use the unique function. So here I've got my 5 inputs and I'm just counting that the unique inputs are 1. So of all the entries input into the cells, there is only one unique value. Here, if I change one of these to south, there are now 2 unique inputs. So this does not equal 1, therefore it's returning an error. As I say, this is by far my preferred solution if you have the unique function because it will work with all inputs. And it's a much simpler formula than using the AND exact example shown previously. If you're looking to validate user input against a range of acceptable values, you'll be pleased to know that Excel's built-in data validation tool will do the work for you. So on the Data tab, you click Data Validation and it will bring up a requester that allows you to select the options to validate that cell. Created a couple of examples here. So on this one, I've chosen a list, with the source being this table here, north, south, east and west. I want an input message, which is the yellow pop-up that appears when you enter the cell. Error alert, I've chosen a stop style if the user chooses something that is not on the list. And on this validation criteria tab, I've chosen in cell dropdown, which is an option available for lists, which gives the user an option to choose from a drop-down list. So if I come out of the cell and go back in, it says choose a compass direction. And as long as I choose from anything on the list, it's acceptable. If I try and type something in that isn't on that list, I get a stop dialog and it won't let me go any further until I either come out of the cell by pressing escape and going back to the original value or choosing a valid entry from the list. This second example is set up to allow whole numbers between 1 and 10. Now, if I were to do that with just values in the cells, this is okay because it will work with those hard-coded values. What I can do in the data validation is refer to those with other cells. For the 1, I'm using I5, and for the 10, I'm using I6. By default, this ignore blank option is turned on. And what this allows us to do is the formula will still work. It will only accept numbers between 1 and 10. But if either of these cells is blank, with that ignore blank option ticked, the rule ceases to work. So I can now enter any value into that cell and the validation rule is turned off. If I go back to the validation rule and choose a whole number between 1 and 10, but turn off that ignore blank, the rule will continue to function, but it may cause some unusual results. 4 works, 11 doesn't. If I now take out that 10, no rule will work. It's trying to validate a number with a minimum of 1 and effectively a maximum of 0. So nothing that I put into this cell is going to work. So that's just something to watch out for on this data validation rule with this ignore blank checkbox. While Excel's data validation tool will help you validate user input, you may want to pull certain rules like this into formula to check outputs. So here I've just built a few examples of how you could look at that. If you had an output value in my example of north and you wanted to check it was on a list, of valid items. You could count the number of times that value appears on the list, and you would expect it to appear once if they're unique values. If the value isn't on the list, the count will be 0 and therefore it will be false. So like the earlier examples, I'm just putting the formula on one side, the value I'm looking for on the other, and if the two sides are equal, it will return true. Checking for a whole number, you can just wrap the output in an integer function and check that the integer of the value equals the value itself. If it does, it's a whole number. For decimal, I'm just checking if something is a number. Date and time are a little trickier. What I've done here is taken the output, I've tried to turn it into a text date, then convert that text date back into a date value. If it isn't a number that can be turned into a date to start with, this will error. So the is error will return true, but we're looking for where it's not an error. So we wrap that in the not function to return a true value. Don't worry too much about the intricacies of this formula. I will provide a link to this workbook in the description of the video. The same with time. You can convert a time value into a time text and then try and convert it back and see if all that works. One thing to watch out for with these is that in this example, I've just got the number 2. So it will turn any number into a date. And that date, the value 2, is the 2nd of January 1900, which it may be a nonsense date for the sake of your workbook, but Excel can still try and turn it back into a date. Unfortunately, Excel is missing isDate and isTime functions currently. So this is probably the best solution you've got without resorting to coding. Check text length. You can use the len function. You can apply validation to any of these functions, but here I've validated the text length by using the AND function. So text length has got to be more than or equal to 4 and less than or equal to 6. A text length of 1 will error in this example. And with these types of error checks, you could wrap them in the not function to check for the complete opposite. Here you've checked for a whole number, for example. Because that's returning true, you could wrap the whole thing in a not and return a false value. So it would check for anything that wasn't a whole number. So that's how you can use data verification and validation to improve the quality of user inputs and formula outputs in your workbooks by checking for and reporting on errors or potential data quality issues. And as I covered in a previous video, which I'll try and put a link to up there somewhere, you can create a dashboard of these types of checks to put at the front of your file to give you a visual one-stop view of the overall quality of your workbook. Thanks for watching this far, and if you found this useful, please hit that like button and consider subscribing to get notified of future content. Thanks for watching.